Welcome everybody. It's Ramachandra from Civil Mech Maths Concepts channel, and this is the 9th in the series of structural analysis. It is regarding finding the moment of inertia for an I-beam. I-beam is the very general beam and very useful beam being used almost in all the structures, steel structures or structures of RCC, and it's very important, very most important beam type, and we will be discussing the I-beam having symmetry about its x-axis and also y-axis. You might have seen railway tracks on which trains move. It is a common scene to see. Rail tracks are laid by steel beams of I shape. They are the I beam. If you see this one is rail, and this type of T beam being used in many factories or on bridges or house structures. That means I-beams are very common in almost all walks of life. We use I-beams, and I want to discuss this to find the center of gravity or the neutral axis of the I-beam, and also to find the moment of inertia of the I-beam with respect to center of gravity. And let us take the dimensions of I-beam as, let us take the dimensions . This is the flange 1 and it is flange 2. This is the web. This is top flange, and this is the bottom flange. There is a top flange, there is a bottom flange, and the top flange and bottom flange are connected by a web. And let us say the thickness of the top flange, let us take as 8 mm. The thickness of the top flange T1 is equal to 8 mm, and thickness of the bottom flange for uniformity, let us take it as T2 is equal to 8 mm, and the width of the top flange, let us take as 100 mm, and bottom flange also 100 mm, and the thickness of the web, that is TW, as 10 mm, and the height of the web HW 100 mm. We have taken for our calculation purpose. I will explain the process of finding the moment of inertia and center of gravity of an I-beam with an example where an I-beam is there whose top flange has the thickness of 8 mm and width of 100 mm, and bottom flange thickness of 8 mm and width of 100 mm, and these two are connected by a web of thickness 10 mm and height of 100 mm. Here also you can define those whatever values are there. Just see, it is the isometric view that rail I have shown on the right hand side. That is the isometric view of T-beam. This is, if you see it here, you will get a better idea. This is the web. This is 100 mm. This is the web. This is the top flange. This is the bottom flange. this is 100 mm. In isometric view, just see, you will have a better idea. 100 mm, and this thickness is 8 mm. This is the thickness 8 mm, and this is the thickness, this is 8 mm, and the thickness of the web is 10 mm. From this you can understand the T-beam is shown in the isometric view. You can appreciate, and we have to find out the moment of inertia. We have to find out the ultimate aim to find the stresses, distribution of stresses in the I-beam. Now, what is the beam theory formula? Beam theory, as per beam theory, as per beam theory, M by I is equal to sigma by Y is equal to E by R. This is very important formula. Please remember. Please don't neglect this formula. Please remember this formula. This will be useful to find the applied stresses in the beams. Very important formula. Beam theory equation, M is equal to moment due to forces, that is bending moment, and I is equal to second moment of area or we can even say moment of inertia. That we represent it as I. Then sigma is equal to applied force, applied stress at a particular point of the beam or member, structural member, and Y is equal to distance from center of gravity of the member for that point under consideration. This is Y coordinate. E is equal to Young's modulus of the material. This can also be called as material of construction. R is equal to radius of curvature of bending. Now, M by I is equal to sigma by Y. That implies sigma is equal to applied stress is equal to M Y by I. This is a very important formula which is to be remembered by all of you. This concept I have explained in my previous lectures in SA6, SA5, SA4, SA3, SA7, that is structural analysis. You see my playlist from my channel Civil Mech Maths Concepts channel, playlist SSC JE, or we can even say GATE, Civil Engineering civil engineering by IIT alumni. In this playlist, you will get structural analysis, previous 8 lectures. In addition to that, you will get the fluid mechanics lectures also. And in engineering mathematics, you will get the engineering mathematics lectures also. So that all these are around 53 lectures are there. You please view them for clarifying the concepts. Engineering mathematics by IIT alumni. Now, sigma, this is the applied stress. Then allowable stress for a particular material is given in the codes. Sigma allowable you can find out from codes. Apply a factor of safety, Fs is equal to factor of safety. Then see that after applying the factor of safety, you see that you ensure that sigma applied does not go beyond sigma allowed after applying the factor of safety. During design process, I will explain this RCC design, steel structure design. During that, I will explain about the factor of safety and how to apply it and how to accept the design or how to accept a particular beam with particular dimensions or whether to reject it. Now in this case, we are confining ourselves to find the center of gravity. What is the question here? To find a center of gravity of the I-beam given B ICG. That is moment of inertia about center of gravity of the given I-beam. Now, to find the center of gravity, what we require? First, let us go for finding the center of gravity of given I-beam. To find that, first we require area of the beam, whether it is with respect to x-axis or with respect to y-axis, the area of the shape of the beam does not change. Area is a constant. Now you see, this is the I-beam. How many parts it has? 3 parts are connected together. Flange 1, flange 2 and web. 3 parts are connected. This is area of the flange 1, area of the flange 2 and area of the web. Then what will be the total area of the I-beam? I-beam total area is equal to sigma AI. That is equal to total of all the areas, all the members areas. That is A1 plus A2 plus AW. Then I-beam area is equal to area of total I-beam is equal to area of total I-beam is how much? This let us not confuse with I, while write area I-beam. Area I-beam is equal to total area is equal to A1 plus A2 plus AW. What is A1? How to find out the A1? What are the dimensions of A1? This is 100 mm. Please see, this is 100 mm. Its thickness is 8 mm, its thickness is 8 mm, and this one is 100 mm, and thickness is, this thickness is 10 mm. This is what is the given beam. Now what will be the total area? The area of a rectangular is width into thickness. Width is for A1, it is width is 100, thickness is 8. For A2, width is 100, thickness is 8. For AW, width is 10, height is 100. That is equal to 800 plus 800 plus 1000. That is 1600 square mm. This is the area of the total area of the beam, I-beam. Now, we are going through as per the procedure whatever we have laid down in the last 4 lectures. For clarity, please see the previous 4 lectures. You will get an idea how to find out the center of gravity. What is center of gravity? Ultimately, center of gravity that y coordinate, let us say center of gravity is lying here. This is somewhere it is lying here. This is the x-axis, let us say. It is somewhere it is lying here like this. This is yc or y bar, center of gravity. And this is the center of gravity of 2, and let us say this is the center of gravity of 2, this is the center of gravity of 1, and this is the center of gravity of web, and this is also center of gravity symmetry. We can say this is the center of gravity of total I-beam also. That we will find out now. Center of gravity of I-beam is, let us say yc, or we can say it is y bar from x-axis, from bottom. And what is the center of gravity formula? Center of gravity is equal to first moment of area divided by area. This is the definition. Here, what is the first moment? First moment is area of that particular part into distance of center of gravity of that area from the center of gravity of the total beam. That is the first moment of area. And what is the area? The total beam area is equal to 1600 square mm, and the center of gravity from the first moment of area we can find out the center of gravity, y bar. That is sigma first moment divided by sigma area, total area. This is the definition. From definition, if more than one part is combined together, then we can say, then sigma first moment of area divided by sigma of the area. In this particular instance, this particular beam is symmetrical about y-axis and also x-axis. When something is symmetrical about x-axis, the center of gravity lies in the center of the total height of the beam. it is symmetrical. Please understand, it is the easiest way to find. This is the total height. What is the total height of the beam from x-axis? It is first flange thickness, that is 8 mm thickness of first flange plus thickness of web plus height of web, sorry, not thickness of web, because it is the height of the web. Height of the web. This is the height of the web. Plus thickness of the second flange. It will be 8 mm plus what is the height of the web? It is 100 mm plus 8 mm. That is equal to 116 mm. That is total height of the beam. As per our knowledge, as per our previous discussions in the previous examples, if a beam is symmetrical about x-axis, then the y-coordinate of the beam center of gravity is equal to total y by 2. That's what we have seen in the previous examples. That is equal to ht by 2. That is equal to 116 by 2. This is 58 mm. This is one of the shortcut methods to find the center of gravity after while seeing the beam itself. If it is symmetrical about a particular axis, half of the total height gives the center of gravity of that center of gravity y coordinate about x-axis. If it is about the y-axis, half of the x-axis distance will give the distance from the origin to the x-axis, that is the center of gravity. This can also be done with the help of the calculus. Regular method, it is a shortcut. This is shortcut which I have explained to you. This is the shortcut. If the particular beam is symmetrical towards about a particular axis. Now, what is the regular method? First moment of area is equal to total is equal to sigma first moment of area, that is equal to double integral y dy dx sigma, that is equal to double integral of first section y dy dx, double integral of second section y dy dx plus double integral of third section dy y dy dx. Here first section is flange 1, second section is bottom flange, this is web. Now, for first flange, x varies from 0 to 100, y varies from, for first flange, we will draw it like this, it is x-axis, this is the first flange. Always try to draw the diagram. This is 100 mm and this is 108 and this is 116. Please try to understand. For the second, this is like this. This is 0, this is 8, this is 100. from x-axis. This is the x-axis, this is also x-axis, because we are finding with respect to x-axis. For the web, this is the x-axis, web starts from here, web ends here. For x-axis, this is almost, web is at the center, total is 100. For web, what is the web thickness? Web thickness is 10 mm. Web height is this, thickness is 10 mm. That means here it starts with 45 mm here and ends with 55 mm here. And it starts with, here it starts with 8 mm here and 108 mm here. This is the web. This is F2. This is F1. This is how we have to do. Now, what is x varies from 0 to 100? X 0 to 100. Y 108 to 116. Here x varies from 0 to 100. Y varies from 0 to 8. Here x varies from 45 to 55. Y varies from 8 to 108. Apply these values in this equation and find out the value of the first moment of area with calculus, regular method. You do it as homework for you. Use the methods which I have explained in my previous classes. Do it as homework and see that center of gravity is equal to sigma first moment of area divided by area is equal to this some value you get from above divided by area is, how much is the total area? Sigma A, it is 1600 is equal to 58 mm. You please find out, do it as a homework, and I don't want to proceed further on calculus method because it's a very simple one which I have already explained how to apply the limits. I have already given you the limits, the values for definite integral, the limits also, the ranges, and you have to find out the value of first moment of total first moment of area of the beam. Now, this is the shortcut to get the 58 mm. I have used the shortcut so that I want to explain you both the ways, so that in the examination if you don't have time to calculate with the help of the calculus regular theorems, then you can apply the shortcut and get the value. If the beam is symmetrical about a particular axis, you can get the other axis coordinate. If it is symmetrical about x axis, you can get the y axis coordinate yc or y bar by simply pointing out the center of the total y length of the beam, y by 2, total y length yt by 2, if it is symmetrical about x axis. If it is symmetrical about y axis, xt by 2. If symmetrical about y axis, you will get xc or x bar is equal to xt by 2. Please remember this. Whenever there is a symmetry, you can directly apply this formula. Now, we have got the center of gravity, we have got the total area. Now, we have to find out the second moment of area, that is moment of inertia of the total beam. Let us draw the beam diagram now. This is the beam diagram. First flange. Now this is the web. Now this is the second flange. It is not to scale. Don't worry about the exact geometry of the beam because it is not to scale. Now this center of gravity is at a point. This is the x-axis, this is the y-axis, this is the x-axis, this is the y-axis. Otherwise let us draw little bit better. Let us draw it like this. Let me draw a little better so that we will draw the axis first so that we can easily. This is the x-axis, this is the y-axis, and the beam top flange and bottom flanges are connected by a web. This is the web, this is the top flange, flange 1, this is flange 2, and the center of gravity is somewhere here. Because of the symmetry, the center of gravity is the geometric center of the beam. Center of gravity is the geometric center of the beam. Please remember this. Then yc is equal to, y bar is equal to, this is 58 mm and this is 100 mm, this is 100 mm, this is 8 mm, this is 8 mm thickness, this is 10 mm. Now we have to find out the moment of inertia, or we have to find out the second moment of area. This is the center of gravity of the first flange, this is the center of gravity of the second flange, this is center of gravity web. Center of gravity of the web and center of gravity of the total beam is same, as it is symmetry about the x-axis, and also from the geometry the web length and the thicknesses of the flanges are symmetrical to each other for this particular geometry. Now we have to find out second moment of area or moment of inertia of I-beam about center of gravity. That is ICG is equal to IXX plus A1 into D1 square, which I have explained in the previous class what it means, plus IXX1, IXX2 plus A2 D2 square plus IXX web plus A web into D web square. This what I have explained in the previous class, please refer to it. The sum of the second moments with respect to center of gravity is the total second moment of area about the center of gravity. Now what is D1? D1 is equal to distance between center of gravity of flange 1 and center of gravity of beam. That is equal to center of gravity of this is 8 mm thickness, means this is 4 mm, and because it is 58, because it is the center, this will be center of the web, this will be 25 mm, because total height of the beam web is 100 mm, not 28, it is 50, sorry. This is 50. Mm. Now this will be D1. This will be D1. C1 to C beam, this is CW is equal to C beam also, is equal to 50 plus 4, that is equal to 54 mm. Similarly here it is 4 mm plus this distance is 50 mm. Therefore D2 is equal to 50 plus 4, 54 mm. For the meaning of D1 and D2 and for better understanding of D1 and D2, please refer to my previous lectures. Now once we got the, now D web is the distance between the center of gravity of the web and center of gravity of the beam. The center of, because of the symmetry, the center of gravity of the web and center of gravity of the beam are lying at the same point. That means distance between CW, center of gravity of web, and center of gravity of beam, that is equal to same. That is equal to CW minus CB is equal to CW minus CW, that is equal to 0. Because they are lying at the same point, then the distance between them is 0. Now we will apply these values in ICG. ICG is equal to, what is IXX1? That is the center of, that is the moment of inertia or second moment of area of the beam or the flange 1. What is the flange 1? That is BH cube by 12. That is IXX1 is nothing but it is not IXX, we can even say ICG1. ICG1. Instead of IXX1, it is just confusing. We can say ICG1 because everywhere we are using ICG. ICG2. This is ICG web. Then ICG1 plus, what is the A1? A1 is 800. And what is D1? 54 square plus ICG2 plus 800 into 54 square plus ICG web. Now we have to find out what is ICG1, ICG2 and ICG web. What is ICG1? If any rectangular shaped beam is there, the value about center of gravity, the value of the moment of inertia or second moment of area is BH cube by 12. What is B? Breadth is 100, height is 8 cube by 12. That is 100 into 8 cube by 12. What is that value? 4267 mm to the power of 4. Next, what is ICG2? That is equal to BH cube by 12. What is the B here? Breadth is 100, H is 8 cube by 12. That is same as the previous one. 4267 mm to the power of 4. Now what about ICG web? For the web, the height is 100 and the breadth is 10 mm. BH cube by 12, B is 10, height is 100 cube, height is 100 divided by 12. What is that value? 833,333 mm. Now total ICG of beam is equal to ICG of flange 1 plus ICG of flange 2 plus ICG of web. That is equal to ICG is equal to ICG is equal to plus A1 D1 square plus A2 D2 square plus A web D web square. Then what is ICG1? ICG1 is equal to 4267 plus what is ICG2? 4267 plus what is ICGW? 833,333 plus what is A1 D1 square? What is the A1 D1 square? 854 square. 800 into 54 square plus 800 into 54 square plus 1000 into 0. dW is 0. This is equal to, let's calculate, 4267 plus 4267 plus 833,333 plus 800 into 54 plus 0. 5507467. This is the value of ICG. What is the center of gravity? 58 mm from bottom. Now here total ICG is equal to ICG1, ICG of that particular part of the total beam plus area of that particular part of the total beam into distance between the center of gravity of the total beam and the center of gravity of that particular part. This you please remember. Remember this one. How it has come, I will explain you now. It is from the parallel axis theorem. We are finding the ICG of a particular item and we are finding the value with respect to the moment of inertia of that ICG with respect to another point of the total beam. Then parallel axis theorem is applied. If you have some ICG of a particular part is there, then you want to find out I dash CG, then that particular part ICG plus area into area of that particular part into distance square. This is the parallel axis theorem. Please remember this parallel axis theorem. This is the parallel axis theorem. This distance is distance between two center of gravities. And this is the area of the part A. ICG is the original part I with respect to center of gravity. You understood? I will make it clear here. ICG is equal to original part moment of inertia with respect to center of gravity. D is equal to distance between two centers of gravity of part and total beam. Then area is equal to part of beam area. Then ICG with respect to total beam of part, which I have explained clearly in my previous example. ICG of total beam of the particular part is equal to ICG of part plus area of the part into distance between the part, center of gravity of the part and center of gravity of the beam, that is D square. Please remember this. In this way, in any book will be written, this is the way you have to remember. If you put just like IXX, IYY, ICG, ICG1, ICG2, then you will be confused. If you have combination of more than one part in a beam, you have to find out the ICG of the part, original part. You have to find out, that is BH cube by 12. And area of the original part and distance between the center of gravity of the original part and center of gravity of the total beam. Then ICG with respect to total beam of that particular part is equal to, this we can say with respect to total beam of that particular part is equal to ICG of the original part plus A of the part into distance between the centers of gravity of the total beam and the particular part under consideration. Then if there are 3-4 parts are there, ICG of part 1, this is equal to ICG part 1. Then there can be ICG part 2, ICG part 3, part 3 total beam. Total beam. It is total beam. This is only ICG of the part, original part. This is when you consider with respect to the total beam. Then when you combine all these values, you will get the ICG of total beam is equal to ICG of part 1 with respect to beam plus ICG of part 2 with respect to beam plus ICG of part 3 with respect to beam. If 10 parts are there, you make it 10 parts. If 2 parts are there, you make it as 2 parts. And if it is a single part, no need to worry. The values will not differ. I think with this you understood well to find the moment of inertia of the I-beam, and it's Ramachandra from Civil Mech Maths Concepts channel. Please review and comment on my videos. In the description I am giving playlist links also. View all videos and subscribe to my channel for regular updates. Best of luck to everybody. Thank you for listening to me and thank you for seeing this lecture. Please subscribe to my channel I will be releasing in the next class. I will be releasing the most important, the toughest beam, that is C channel. C channel, which is unsymmetric. I am going to release the topic lecture on C channel. C channel. Let me do this in the next lecture from Civil Mech Maths Concepts. Thank you. Thank you for listening to me. Don't miss the next lecture on C channel. I will be making the complex things as simple as possible so that you can understand the concepts. At the same time, you will be able to do the mathematics and calculations faster. Thank you. Thanks once again. It's Ramchandra from Civil Mech Maths Concepts. Best of luck to everybody. Thank you.